Hi, welcome back to the Power of Model Drawing. Now today we are going to look at before and after model, and we are going to look at fractions, and we are going to revise the concept of what is before and after and recognize the difference unchanged. So what is the difference unchanged? When you have equal number that's added or removed. So when you see equal number that's being added or being removed, then you have to recognize that the difference is unchanged. Alright, so let's go into example 1 and you'll understand what I mean. Now, Sarah and Claire had $180 and $260 respectively. So it means the first number belongs to the first person, second number belongs to the second person. Now, each of them spent an equal amount of money. When you see that, it means that the difference is unchanged. Right? For example, if I have $10 and you have $3, what is our difference? Our difference is $7, right? And what happens if we both spend $2? So if both of us, we spend $2, then we will get lesser money. So my money will now be $8 and your money will now be $1, right? So $3 minus $2, you have $1 left. What is our difference? Our difference is still unchanged. So when you see equal number being spent, or if you see equal amounts being received, then you have difference unchanged. Okay, so what do? So now we draw the model. So let's draw the model starting with before. So when you draw a before and after model, you always start with the before model first. Okay, so again, you always start from the beginning when you start drawing. So Claire had 180. So Sarah has lesser money, Claire has more money, right? Now, if you're not sure how to draw the model, or you don't know how it's going to look like, then what I would suggest is put the numbers outside the boxes so that you can do something inside later. If you need to cut the model, you can still do that. If you want to put anything else in the boxes, you can still do that. So now we keep the boxes clean, empty, alright, so that we can do cutting later if we need to. So Sarah has 180, Claire has 260. Alright, that is their at first. Now each of them spend equal amounts of money. Alright, so what do? Now we can cut, right, using dotted line to show equal parts. So there is something called dotted line that you can use to help you to cut out equal parts. So I can do something like this, dotted line, alright, and you can see that you have equal parts, right? And what happened to these equal parts? It means that Sarah and Claire, they spend these equal parts. Alright, so how do you draw the after model? Now, the after model is quite easy. Now, Sarah, Claire, so Sarah will have lesser money. So I start from the dotted line and I draw Sarah's box. Okay? And then Claire will also have lesser money. So until you can see her money also became shorter. Alright, then what happened next? Sarah now had 1/3 as much as Claire. So which means that Sarah had 1 box and Claire has 3 boxes left. So 1/3 refers to 2 different groups, 2 different persons. So Sarah has 1 box. So there's 1 box for Sarah, so that you can call it 1 unit. And then Claire will have 3 boxes, so you count into 3, and every box will be called 1 unit each. Okay? Alright, so how much did they spend all together? So your question mark will be to find the shaded parts, and then you plus them together. Alright, and your model is done already. Okay, so once your model is done, you look at the model and you study the model and see how to work out the answer. So the difference is unchanged. So can you find the difference here? Which is 260 minus 180. So your difference is $80. So you put the difference here. And how about the difference in the after model? Will also be the same. Alright, and then you can see that Claire has 2 units more than Sarah in the after. So 2 units more is also $80 more. So 1 unit will be 80 divided by 2. So your 1 unit is $40. So once you can find 1 unit, you can find many things. You can find Claire has how much money in the end, which is 3 units. And that will be 40 times 3. So Claire has $120 in the end. And Sarah has 1 unit in the end, which is 40, right? And then you can fill in the before boxes as well. So if Sarah has 40 in the end, then this must also be 40, right? And then Claire has $120 in the end. All right. Okay. So now can you find what is the question mark? Yes, you can. You take 180, which is Sarah's money at first, and you minus 40. All right. And you will get how much is Sarah's spending, which is $140. So Sarah spent $140. Then how about Claire? Now, Claire, you take 260 and you minus 120, you also get $140. So you can see that both of them spend equal amounts. So how much did they spend altogether? So you take 140 and then you times 2. And you will get $280. So both of them spend $280 altogether. Alright, so that's how you draw the before and after model, and the difference is unchanged. Alright, and how to draw the equal parts, or how do you cut away the equal parts? You make use of dotted lines to help you to cut equal parts. Alright, and then you can see that that both of them have spent equal parts. Okay, alright, let's go to question number 2, and let's look at one more example. Now, the red buttons is 3/7 of the blue buttons in the box. So which means the red has 3, the blue has 7. So this fraction refers to two different colors. When June adds another 18 red and 18 blue. So when you see equal number being added, the difference is unchanged. Then there are 60 more blue buttons than red buttons in the box. So what is the total number of red and buttons in the end? So this is a before and after problem, right? So then we draw the model. So your before model, and how do you draw the before model? You follow the first sentence. You see a fraction there, so make use of the fraction to draw your model. The red has 3 and the blue has 7. Okay, so it's actually quite easy if you understand how to interpret the fraction. So yeah, 1, 2, 3, 4, 5, 6, 7. So the blue has 7 boxes. Okay, when June adds another 18 red and 18 blue, so what will happen to the after? Now, model drawing is about using logic, right? Using some logical thinking. If you add equal number to the red and the blue, then their rectangles will become longer, right? So how do I draw the equal parts added? I make use of dotted line, okay? And when you draw the dotted line, it means you're going to have equal parts, right? Added to them later. So the red has 3 boxes, which is the before, and the blue has how many? The blue has 7 boxes, which is the before. Alright, and you can see that their rectangles will become longer later. Alright, so that's how you draw. Okay, draw something like this. Okay, so you can see that the red still has 3 boxes and the blue still has 7 boxes, right? But because you add equal number to each color, so I'm going to draw equal boxes added to each color. So now you can see that I have 2 equal boxes added to each color. And how many added to each color? 18 each. So you added 18 red and 18 blue. Okay? Alright. And now there are 60 more. Alright, 60 more red. 60 more blue than red. So this is the difference, which is unchanged. Alright. And then, yeah, until here. So what is the total number of red and blue in the end? So this is the question mark. Alright, so that's how you draw out the problem, right? Now again, like what I said earlier on, when you draw the model, it may not be exactly the same as my drawing, but you are still drawing out your own model. So you're going to use your own model to work out your answer later. Alright, so let's look at this model, and if the difference is unchanged, then the difference in the before must also be the same. Okay, and there's no more drawing, so you can start calling every box 1 unit. So now all the boxes will have 1 unit. Okay, alright. And now you look at how many boxes is 60. So how many more unit is the blue than the red? Okay, so you have the blue has how many at first? You have 7 units of blue and you have 3 units of red. So you have 4 units of more blue than red at first. And that 4 units is your difference. Okay, your 4 units more. So your 4 units more is 60, right? And then you can find 1 unit. So your 1 unit will be 60 divided by 4. So your 1 unit is 15. And once you can find 1 unit, you can solve the problem. So you can find many things. You can find how many red over here and how many blue over here, right? Okay, so let's find. So you have how many blue? How many blue here? Now there are 1, 2, 3, 4, 5, 6, 7 units. So 15 times 7, right? 15 times 7, 105. Okay, so let's put down 105, and then there are 3 units of red. So that will be 15 times 3, which is 45. So you put down 45. Okay, and now can you find the total marbles in the end? You just take 18 plus 18 plus 45 and plus 105. Okay, and that's how you get the total marbles in the end. Alright, so let's work out. So you have, alright, there's a lot of numbers to add. So 18 plus 18 plus 45 and plus 105. So how many marbles are there all together? Now you will get a total of how many marbles? Okay, how many buttons? Let me see. So you have 105. You have 105 plus 45. That will be 150, and then 18 plus 18 is 36. Plus them together, 186. Yes. Alright, so you have 186 buttons altogether in the end. Okay, so that's how you draw out the before and after model with the difference unchanged. Alright, now, well, is there a shorter way to get the answer? Yes, there is actually a faster way to get the answer. So different ways to get the answer. For example, you can add all the units in the after model, which is total 10 units, right? 10 units. And then 10 units will be 15 times 10. Right, 1 unit is 15, 10 units will be 15 times 10, you get 150, and then 150 plus 18 plus 18. So you have lesser steps, but in the end you will still get the same answer. Alright, okay, now let's go to example or practice problem 3. Alright, practice problem 3, and now we look at an age-related problem. Alright, so I'll give you 10 minutes to try to work out this problem. It is an age problem, but the concept is still the same, method still the same. Right, the age difference is always unchanged. So are you able to draw the model and then use the model to solve? So your time starts now. So have you solved the problem? Alright, let's read. Now, Sandy's age is 1/8 of the mother's age now. This is the before. Her mother is 32 years old now. So before again. So in how many years time, which is the future or the after, will the mother's age be 3 times of Sandy's age? So that is the future, right? The after. So what is the change? The change is you have some years added to them. In how many years time? That is the change, right? Okay, now, so let's draw the model. So you have the before model first, right? You always start with the before model. Sandy has 1 box, and the mother has 8 boxes. So you draw a longer rectangle. 1, 2, 3, 4, 5, 6, 7, 8. Alright, and her mother is 32 years old now. So you indicate arrow sign, 32 years, and you're until here. Now, in how many years time will the mother's age be 3 times of Sandy's age? Now, with some logical thinking, you will agree that their rectangles will become longer because they will get older. So, in how many years time will the mother be 3 boxes or has 3 boxes? So the mother is going to draw, you're going to draw a rectangle for the mother which is longer than before and cut into 3 boxes. Alright, 3 boxes. That's 3 times. And Sandy will have 1 time, which is 1 box. Okay, that's how you draw 3 times as many as Sandy. So the mother is 3 times, or the mother's age is 3 times as many as Sandy. Okay, so in how many years time? Can we put the question mark in the model? If you can't put the question mark, then you don't have to put the question mark. Okay, but actually you can put the question mark. You can put the question mark over here. That will give you how many years time the mother will be 3 times, right? So the question mark can actually be indicated on the model. But if you don't know where to put the question mark, then it's okay, right? You can choose to not put the question mark if you are unsure where to put it. Okay, so let's look at the model and let's use it to solve. Now you can see the before model, the mother has 8 units, which is 82. So 8 units is 82, or 32, sorry, 32. So 1 unit will be 32 divided by 8. So 1 unit is 4. Then you can find Sandy, because Sandy has 1 unit. So if Sandy has 1 unit, Sandy is 4 years old now. And if we know that the difference is unchanged, then you take 32 minus 4, 28, to get the difference. Right? You need to get the difference. If you know the difference is unchanged, get the difference. And then in the after model, there's a difference as well, and that is also unchanged. Okay? And then you can see that 2 boxes. Do I call these 2 boxes 2 units? I will not want to call 2 units because you already have caught units already, and the units that you have caught, the boxes are smaller than the boxes that you see in the after, so they are much bigger. So I won't call them units. Then what do I call? Well, you can call them parts. All right, parts. All right, but if you don't want to call them parts because it seems confusing, all right, then don't worry. You can just take 28 divided by 2 boxes, and you can get 14. All right, so you can do that. All right, or otherwise you can call the boxes parts. All right, and then this box will be 14 as well. Every box is the same. And then Sandy will have 1 box, which is 14. Alright, so you can actually call parts and units, or if you don't want to call parts, then you can just put the numbers inside, alright, into the model. Okay, so now can you find how many years time will the mother's age be 3 times of Sandy? Well, you look at the mother's age. How old is the mother in the future? So if you look at the mother's age in the future, that'll be 14 times 3. Isn't that 42? Right? So the mother is 42 years old in the future, which is don't know how many years time. But how old is the mother now? The mother is 32 years old now. Then how many years later will the mother be 42 years old? So you take 42 minus 32, and that will give you 10 years time. Right? So in 10 years time, the mother will be 3 times as old as Sandy. Alright, then if you want to check your answer to see whether is the answer correct, you look at Sandy. How old is Sandy in 10 years time? That will be 14, right? Sandy will be 14 years old. And then how old is Sandy now? Sandy is 4 years old now. So in how many years time will Sandy be? Alright, in how many years time will Sandy be 14 years old? So you take 14 minus 4. So Sandy will be 14 years old in 10 years time. So you can see that your answer is correct, right? Okay, so what have we learned so far in this lesson? We learned about the difference unchanged, and when you see the difference unchanged, what do? You make the difference the same, right? And then you draw the before and after model, which is quite easy to draw. All right. Okay. So in the next lesson, we will look at before and after again, but we are going to look at everything changes, which is much harder now. When something is unchanged, it's easy. You just make it the same. All right. Make the number the same. And what is unchanged, you make the number equal, right? Make the number the same. But it gets a little harder when everything changes, right? Then you have to think a little bit more, right, to work out the answer. Okay, so we will look into everything changes in the next lesson. So stay tuned for the next lesson.